factor of 2, and then we'll go over it. I think if you go to your drive and then open it up and then press print, those are options that we've been. Yeah. That's good.
It's not running.
Are we supposed to sharing or?
No, we're going to go over it together. I'm just giving everybody a chance to catch up. I'll write out all the pre-image coordinates now. So these are all our pre-image coordinates, W, X, Y, Z. And now to perform the dilation, what you're going to do is you're going to multiply 2 times the X coordinate and 2 times the Y coordinate. So that's why I have 2X, 2Y in the image. And we could actually do this in our heads, can't we? So for W prime, we're going to do -2 times 2 is a -4, and 2 times 2 is 4. So now we plot that. So we're at -4, +4. That's W prime. And then 0 times 2 is 0. 2 times 2 is 4. So now we're at 0, 4. For X prime. And now 2 times 2 is 4. -2 times 2 is a -4. So we're 4, -4. And this is Y prime. And then last but not least, -2 times 2 is a -4. And 0 times 2 is 0. That's our Z prime. And then we connect. And does it make sense that our new image is bigger than the old image? Does that make sense? It does make sense. Why does it make sense that our new image is bigger than the old image? Because our scale factor was bigger than 1. If our scale factor is between 0 and 1, those positive fractions, then it's going to be smaller. We'd be reducing because when you multiply by a fraction between 0 and 1, you're really just like dividing ultimately. But if the scale factor is bigger than 1, if the scale factor is bigger than 1 and you're multiplying by a number that's bigger than 1, you're making it bigger. Your number is getting bigger. All right. Let's go on to ratios and proportions. Definition. A ratio is a quotient of two numbers. And there's a very specific way we represent ratios, and it could be represented in multiple ways. But the thing to remember is that the order does matter. So in this, it says the ratio of 5 meters to 3 meters can be written in the following ways. See how in the wording the 5 came first? It's saying 5 to 3. That means the 5 always has to come first. Whatever is written first in the words has to be written first with the symbols. So 523 could be a 5:3. That's probably the way you're most used to seeing ratios, with the colon. The way you're going to see me writing ratios is actually with a fraction bar. So 5 fraction bar 3. Since a ratio is a quotient means division, the fraction bar means division. You could write it with the word 2. So you could say 5TO3, 523. And the last way is with the little baby division sign that we learned in elementary school, 5 division sign 3, which you'll never see me using. The other 3, you'll see me using those. The baby division sign, you'll never see me using. All right, let's keep going. So let's look at a problem. A piece of rope is divided in the ratio of 3 to 4. If the rope is 42 inches long, find the length of each piece. Okay, so I'm going to draw a diagram here. Here's my original rope, here to here. And how long is that original rope? 42 inches long. But then something happened to it. It says the rope is divided. So we're going to take this rope and we're going to divide it. That's me dividing the rope. Now, when we divide the rope, it's saying it's splitting in the ratio of 3 to 4. Remember, I used to say this from chapter 1. The minute you take numbers out of a ratio, I can't just write 3 and 4. What do I have to put along with it the minute I take it out? An x. So this is going to be 3x and 4x. And now if I add those two parts together, 3x plus 4x, shouldn't that equal the total length of the rope, which is 42? So that is our equation. 3x plus 4x equals 42. Now we're going to combine our like terms. So we now have 7x equals 42. Divide both sides by 7. And we get x is equal to 6. So now it's saying find the length of each piece of the rope. Now that I know that x is 6, how do I find the length of each piece? Plug in for x. So my 3x is going to be 3 times 6, which is 18 inches long. And then the 4x is going to be 4 times 6, which is 24 inches long. Because we express ratios as fractions, what do we always have to do to a fraction? Or what do we always have to make sure of with a fraction? That it is what? So like if I have 4 over 6, I'm going to say, oh, that's not the best answer. What should we do with that 4 over 6? It's the word I'm looking for. Jonah? We have to simplify it. Anytime we have a fraction, we need to simplify the fraction. It's the same thing with ratios. Because ratios are allowed to be expressed as fractions, we need to simplify the ratios. So right now, if I start off with 20 over 50, that's not in simplest form. I can divide top and bottom by 10, and then I'll get 2 over 5 is my ratio in simplest form. And now sometimes I won't represent it as a fraction, but we'll need to know that we can change it into a fraction. So 54 over 36, or 54 to 36, I'm going to write as 54 over 36. So I'm going to write it as a fraction, and now I'm going to reduce it. I can divide top and bottom by 6 to start. And then 54 divided by 6 is 9. 36 divided by 6 is 6. Am I finished? No. Can I now divide by 3? So when I divide by 3, I'm going to get 9 divided by 3 is 3. 6 divided by 3 is 2. So 54 over 36 in simplest form is 3 over 2. Yes. I'm sorry? A charger? There's one on my desk. All right, you guys do letter C. Yep. Okay, so for letter C, we have 8 to 56. I'm going to divide top and bottom by 8, and we get 1 over 7, or 1 to 7. How many people got that? All right, let's keep going. Definition. A proportion is an equation stating 2 or more ratios are equal. To solve a proportion, we can cross multiply. Okay, let's keep going. Do some practice problems. Okay, solve for x. So whenever you have one fraction, an equal sign, and then another fraction, cross multiplying is when you multiply on a diagonal. Like that. That's what cross multiplying is. But before we cross multiply, what you want to look at is, can I reduce either one of these fractions? So I can't reduce or simplify x over 6, but can I simplify 7 over 42? We can. What number divides evenly into 7 and 42? 7. Good job. So I'm going to divide top and bottom by 7 before I cross multiply. So I always reduce or simplify my fractions before cross multiplying. So we have x over 6 is equal to 1 over 6. At this point, I can figure it out in my head. What number over 6 equals 1 over 6? Wouldn't that number have to be 1? 1 over 6 has to equal 1 over 6. But let's say you didn't know that. Let's say you wanted just to solve normally. What you would do is you would cross multiply. So you multiply on a diagonal, and what you would get is 6 times x, which is 6x, equals 6 times 1. I'll bring it up here. So now we have 6x equals 6. And now we solve this equation. So we divide both sides by 6, and we get x is equal to 1. Okay, next one. All right, can I simplify either fraction at all? Can I reduce it? No, we can't reduce any fraction. So now I'm just going to go straight into the cross multiplication. So we have x plus 2 over 8 equals 5 over 4. So when I cross multiply, now we want to be very careful here. I'm going to get 4 times x plus 2, but because x plus 2 is a binomial, because of that plus sign, I have to put that x plus 2 in parentheses. And then on the other side, I'm going to get 8 times 5. When you have a number and then parentheses, what do we have to do with that number? You have a number and then parentheses. Jack? Yeah, you have to distribute it in. So I have to multiply it with everything inside the parentheses. So 4 times x is a 4x. 4 times 2 is 8. And then 8 times 5 is 40. And now this is a normal equation that we know how to solve. I'm going to bring it up here. So now we have 4x plus 8 equals 40. I'm going to subtract 8 on both sides. So now we have 4x equals 32. Divide by 4 on both sides, and we get x is equal to 8. I want you guys to try letter C on your own. You guys are trying letter C. Actually, try C and D on your own. Try C and D on your own, and then we'll go over both of them. Yes.
I don't want to disrupt, but like, can I talk to you for a second?
Can you talk to me?
Yeah.
Why?
So basically, like, this weekend, I was at a mom with me, like, 2 days, I forgot to study. I was gonna study during
Bye,
school.
bye. We'll talk during class. You don't come interrupt this class for that. Go, go. All right, we ready? So now we're going to cross multiply. So we have 3 times 4 plus x is equal to 5 times x. Do we need the parentheses around the 4 plus x? Yeah, because that's what tells us we have to distribute in. So 3 times 4 is 12. 3 times x is a 3x. And then 5 times x is just 5x. Now what ends up happening is we have variables on different sides, so I need to subtract that 3x over. And when I do that, I have 12 is equal to 2x. And now we know how to solve this. So we divide both sides by 2. So x is equal to 6. How many people got that? Great. So now next one, I wanted you to finish this one also. Again, you're going to cross multiply. So you're going to end up with 7 times the quantity of 2x plus 5 equals 9 times the quantity of 2x plus 3. We're now going to distribute that 7 in, and we will have 14x plus 35 is equal to 18x plus 27. Again, I have x's on different sides, so what I'm going to do is I'm going to subtract that 14x on both sides. So now I have 35 is equal to 4x plus 27. Now we're going to subtract that 27, and we're going to get 8 is equal to 4x, divide by 4, and we get x is equal to 2. All right, let's move on. So now let's talk about word problems. It says on a map, 6 centimeters represents 16 miles. What distance is represented by 9 centimeters? We're definitely creating a ratio here. And the reason I know we're creating a ratio here is because we're comparing 2 different units. Do you see how it says on a map, 6 centimeters represents 16 miles? So the 2 units are that we're comparing are centimeters and miles. When you start a word problem, you have to decide in the beginning which unit you want in the numerator and which unit you want in the denominator. Once you decide, you have to stay consistent with that the rest of the time. So I'm going to say centimeters will be in the numerator and miles will be in the denominator. So anytime in this problem, I make a ratio, centimeters will have to be in the numerator, miles will have to be in the denominator. So here they're telling us 6 centimeters is equivalent to 16 miles. So I made a 6 over 16. And then it says, what distance is represented by 9 centimeters? Where do you think I put that 9 centimeters? In the numerator or the denominator? Based on what I decided for this problem. In the numerator, because I said centimeters always go in the numerator. So it says what distance represents 9 centimeters. So 9 will go in the numerator. And it says what distance? How many miles does that represent? So I'm going to put x, that's what I'm trying to find, in the denominator. Did I lose anybody with how I set this up? Now, before I cross multiply, does anybody see anything I can do to make my numbers smaller? Can I divide 6 over 16 by 2? And when I divide by 2, I get 3 over 8 is equal to 9 over x. And now I cross multiply. So I'm going to bring it up here. And we're going to have 3x is equal to 72. Divide both sides by 3. and we get X is equal to 24. Does that sound right? 24? Nope, 28, right? No, 24. Thanks for your help, guys. Thanks for the help. So what distance does 9 centimeters represent? 9 centimeters represents 24 miles. We have to put the units. We have to label it. So X equals 24 miles. All right, next one. A car can travel 300 miles on 9 gallons of gas. So what units are we comparing? You got it, miles and gallons. So I've decided in this problem, I will have miles in the numerator and gallons in my denominator. If you wanted to be different, if you wanted to do gallons in the numerator and miles in the denominator, could you do that? Absolutely. Once you decide, it doesn't matter how you start the ratio as long as you stay consistent in that ratio. So I chose miles to gallons. If you wanted to do gallons to miles, you'd be perfectly fine. So now it says 300 miles. So that's 300 in my numerator goes on 9 gallons of gas. So I have 300 over 9 equals how much gas is needed to travel 750 miles. Where am I putting that 750? Numerator. And how much gas? That's talking about gallons. So I'm going to put X in the denominator. Before I cross multiply, does anybody see anything I can do? Yeah, we can divide 309 by 3. So we end up with 100 over 3 is equal to 750 over X. And now we cross multiply. So when I cross multiply, I get 100 times X is equal to 3 times 750. So now over on the side of my paper, I'm going to work out 750 times 3. 3 times 0 is 0. 3 times 5 is 15. I'm going to put the 5 and carry the 1. 3 times 7 is 21 plus 1 is 22. So now we have 100x is equal to 2,250. And now we need to solve for x. So I'm going to divide by 100 on both sides. Does anybody remember the rule when you're dividing by a power of 10? So the rule says if you're dividing by a power of the 10, you put your decimal point wherever it's supposed to be. Since this is a whole number, my decimal point's on the end. For however many zeros you have, that's how many places you're moving to the left. So since 100 has 2 zeros, that means I'm going to move 2 places to the left. And so 2,250 divided by 100 will be 2250 or 22.5 gallons. Did you guys know that? Power of 100 division shortcut? All right, let's say you didn't know this. How would you do this problem? You would have done the numerator inside the house and the denominator outside the house. So 100 doesn't go into 2. 100 doesn't go into 22, but 100 does go into 225 twice. So then you're going to say 2 times 100 is 200, and then you subtract. 2 minus 2 is 0. 2 minus 0 is 2. 5 minus 0 is 5. And then you bring down that 0. 100 goes into 250 twice again. So that's 200. When you subtract, you get 50. There's no more numbers to bring down. So what you do is you add that decimal point in and put a 0 to bring it down. 100 goes into 500 5 times. 5 times 100 is 500. And then that's where we stop. So here, again, you'd get X is equal to 22.5 gallons. And isn't 22.5 the same as 22.50? They're the same. Was that the end of it? Is there more? Or are we done? Okay, so guys, we are done, which means what? You can start your homework.